Hi, my name is Josh, and I'm representing the RF Interrogator team. Along with me in this presentation will be Brandon, Jonah, Daniel, and Seth, each talking about their own respective portions of the project. I'm going to lead off with Brandon. He's going to discuss the transmitter.
So from the last time with the last video, we have finished the transmitter design on the PCB board and we have manufactured the PCB as well. We have tested the PCB. So we have 5 boards right now. So we made one didn't work and we found a lot of issues with it. So then design 2, the second board, was where we made all the changes and now we have a working PCB board. So now we can have the full ascension of the transmitter and the receiver board. And now off to Jonah to talk about the receiver board and some new design changes.
Hello, I'm Jonah. I've been working on the receiver side and also the DSP side, and I created a layout for the previous receiver board in ADS in order to simulate the stability and solve the issue of the oscillations. And I've also been working with Daniel on the DSP side to implement the HackRF as a substitute to the old DSP and receiver board to create a proof of concept for our project. And HackRF is just an immediate solution for the receiver board, but in the long run it'll have to be redesigned and simulated in ADS. And I've also been testing the GNU radio scripts developed for the HackRF to characterize the frequency response from the passive tags. And I'll be passing over to Daniel to talk about the DSP and receiver side.
Hi, I'm Dan, talking about the receiver and DSP sections. So we've developed a dashboard with GNU Radio and Python that has a number of displays for viewing the time domain of the waveform, the frequency spectrum, and the magnitude of the signal. And it has controls for adjusting the tuning frequency of the HackRF, the bandwidth of the front-end filters, the sample rate, the gain, and other parameters like that. It includes the algorithms that we developed for the TI DSP board, the peak finding and peak timing routines, and it has a display for showing the frequency calculation that comes out of those algorithms. So far we've tested it in the loop with the transmitter and the results have been promising, but some more work needs to be done with calibrating the calculations and just getting everything fine-tuned. Now, we need to remember that this setup is just temporary, and eventually we'll need to return to using the dedicated receiver and DSP boards. But the setup does work well as a proof of concept, and it's pretty easy to work with. We've also been looking into alternative solutions for the DSP in addition to the TI boards, which Seth will talk about next. Thank you.
I'm Seth Dunbar. I'm going to be talking about an alternate DSP solution we've been working on using the Renesas S7G2 board. We chose this board for its user interface. It has the screen that we can display the results on, and its sampling rate is 2.5 million samples per second, which should be plenty sufficient for this project. So here we have our setup. This is the Renesas board, and I'm using an ADK to act as a signal generator. So I have the signal generator output connected to the Renesas ADC input. So here you'll see the software for the ADK on the left and the software for the Renesas board on the right. So I'll go ahead and start generating the 20 kilohertz sine wave here. I'll go ahead and start the software on the Renesas board. And I'll open the memory monitor. And here we have a 20 kilohertz sine wave being sampled by the Renesas board. I can go ahead and I can change this to a ramp signal. And I will restart the software on the board. Pull the memory monitor up again. And here we have our 20 kilohertz ramp signal. So some of the things we're looking at doing in the future with this is we want to implement our peak finding algorithms that we had previously developed on the Texas Instruments board, and we want to implement them to display onto the Renesas board screen here. So that's it. See you guys next time. Thank you.